All right, so this section is mainly a section dealing with word problems, dealing with optimization, modeling being your keyword that we're dealing with word problems here as compared to straight functions like we saw in a previous section or on a previous quiz. So our goal is to tackle word problems, but turn them into functions we can then optimize, finding either local or global maximum. So the question I want to tackle today, a couple examples. Two numbers have a product of 784. So I'm going to tell you the product. Oops. Find the minimum value of their sum. And I should say here positive numbers. Question?
Why would he find the minimum? Like, shouldn't there only be one?
No. I'm not necessarily saying integers. There's lots of different factorizations of 784. So what we know that we have two numbers, x times y equals 784. And we want x plus y to be minimized. So what you're going to see in questions like this very often are two different things popping up. This is to be optimized. And this is your constraint. So this is the thing we're going to try to turn into a function. But we're in Calc 1, and we can't have a function of two variables. So I need to remove one of the variables. So I'll write it currently as s equals x plus y. But I want to write this in terms of a single variable to get this in terms of a function we can then optimize. Well, taking the constraint and solving for y gives me that y equals 784 over x, or that I now have a function s of x equals x plus 784 over x. Key point now is we have a function of a single variable which we can hope to optimize. So doing our due diligence, let me write this first as x plus 784 x to the negative 1. To make s prime of x pretty straightforward as being 1 minus 784 x to the negative 2. S prime of x does not exist if x equals 0. But s of x doesn't either. So again, we should always be checking for where this thing doesn't exist. And this will be bad at x equals 0 because we're taking 0 to a negative exponent. But the original function here won't exist either, so it's not even in the domain. Check. So we kind of get three critical points like we saw in our global extrema section. We do have a lower bound of the number of 0. Now we can't actually use 0 because 0 times anything is 0. We also get the number we're going to get from here in just a second. We also get infinity. We kind of get these from the start. This is kind of our bounds. In certain questions, you'll have more strict bounds, but we could have as small as 0 and up to infinity. Check. So to find the middle critical point, we set the derivative equal to 0. So taking 1 minus 784 x to the negative 2 equals 0, or that 1 equals 784 x to the negative 2, or doing a couple different ways of doing this algebraically, multiply both sides by x squared. X squared equals 784. Yes? Which, if I'm not mistaken, gives you x equals plus or minus 28. Now, one of these answers I'm going to take, one of these answers I'm going to throw out. The negative answer I'm going to throw out because we're talking strictly positive values. Otherwise, this question is going to have some weird answers where we get things like negative infinity. So positive 28 is the only one I really care about. So I now have a table of all the critical values, like we saw previously in another section, where I also use the bounds as critical. Putting these into the original Sx function here, putting in 0 gives me 0 plus something that goes to infinity. So that would give me infinity here. That's probably not the minimum. Putting in 28 gives me 28 plus 784 over 28. Well, 28 is the square root of 784. So this is 28 plus 28, which is 56. Infinity will give me infinity plus 0, or simply infinity. So looking at this, if we're going to have any global extrema, it's on this list somewhere. So what do you guys see? Well, there is no biggest thing. We can't actually get to infinity. But I do have a minimum. The smallest thing I see is 56. So this is indeed the smallest sum. Now, this is where you have to be careful with word problems. I phrase this differently than sometimes books will. I asked you for the minimum value of their sum. The correct answer to this question is 56. It would be very easy to ask you, what are the two numbers? The two numbers would have been a different question, same work, than 28 and 28. But again, just be careful on how you answer the question. What I actually asked you here was find the minimum value of the sum, not find the two numbers. Okay? That would not be a huge, huge deduction on a partial credit test, but something like web work where you put something totally wrong, it's just going to say no. Questions? No? All right. Type of question that typically drives students nuts, if I can pull it up here. Apparently I can't do much of this. All right. Not sure why it's not moving with me. I don't know why. We're trying to do global extrema. We saw that in our section on global extrema. We always include bounds as possible extreme points. And the bounds here are a little bit artificial, but necessary to at least consider. All right, so a type of question that often drives people nuts are questions like this one, where you have a graphical component. We're given a function. In this case, it's f of x equals x squared over 3 minus 50x plus 1,000. And we didn't have a figure drawn in it. So let me give a quick sketch here. This is the point x f of x, where f of x equals, to make sure the numbers come out somewhat clean, x squared over 3 minus 50x plus 1,000. And the goal is to maximize the shaded area. Well, if I think of this being xy, the area is x times y, or x times f of x, or x times x squared over 3 minus 50x plus 1,000. Okay? Now, this gives me that the area function in terms of simply x is x cubed over 3 minus 50x squared plus 1,000x. The question, though, is what's the domain of the a function? Well, the smallest x can be, and it's kind of a cheater value, is 0. And I say open and a cheat value because if I actually set x equal to 0, I'd have it along the y-axis, and I wouldn't have a rectangle, I'd have a stick, which would have 0 area. The other point is some x-intercept of the original f of x function. But I would make that one rounded as well, because at that point, f of x is 0. So the graph would be a horizontal stick. So you can solve for it if you want to, but this one gives me a vertical stick. This one gives me a horizontal stick. Both which are going to have areas of 0, either the height or the width being 0. Okay, so to find the other critical point, we can take our function, sorry, not that function, this function, find a prime of x, which should give us x squared minus 100x plus 1,000. Which does not have a great solution. 10,000 minus 4,000. No, it's going to get fairly ugly. The x values here that work. So if x squared minus 100x plus 1,000 equals 0. I'm worried I made a mistake already, though. Let me double check something. X cubed, 50x squared, 1,000x, x squared, minus 100x. Yep. X is going to equal 100 plus or minus the square root of 100 squared minus 4 times 1 times 1,000, all over 2, which is 100 plus or minus the square root. With a little bit of work here, this should come out as 6,000. Over 2, which can be cleaned up a little bit as 50 plus, take out a 10, take out 400, which is 20, 10 root 15. I think is the correct value. Plus or minus. The key point, though, this graph now will have 2 different spots we're talking about, which is going to kind of come underneath and come back up, because notice this graph is definitely concave up, with the leading coefficient being positive. Think of how parabolas work. So only one of these values is going to happen before the first x-intercept. And it's not going to be 50 plus, it's going to be 50 minus. And that should be the value we want. And notice that sometimes these questions are worded to your benefit. The question specifically here says to focus only on the region between 0 and 20, which means that this would not be a consideration of yours. This would be given to you. But it's good for discussion. And this positive value becomes ridiculous at that point. We can't do it because it's bigger than 20. The negative is the only one that would fit the region. Okay?